Right, welcome to the Cup of Comp site. Today we're going to walk through a tutorial that's on this website, and the tutorial is to create your first GraphQL API. So credit to Args for creating this. I'm just going to walk through it, and so you'll have an example video of someone actually doing the tutorial and you can follow along. Okay, so we've already done a video about what GraphQL is. Make sure to check out the intro video we went through. But just a quick recap, the point of GraphQL is instead of using REST, where you can't specify the exact fields that you want, and you have to potentially hit multiple endpoints, you can use GraphQL, and for GraphQL, you can specify the fields that you do want. And from the client side, it seems like there's just one endpoint, and that could be for multiple things. So if you want product information and user information in the REST API, that could potentially be two different endpoints, which translates to two different requests. But with GraphQL, you can make one query and get information for both of those things, for both the user and the product as well. So for the code, we first need like a sort of, okay, I guess this will just give us a starter file for the tutorial. So I'm going to run this command. Okay, so this seems like it's cloned the project, and the files I've gotten are server.js. I got this package JSON, which is fine. Of course, a git ignore. Type defs, resolvers, models, and configs. So I think the tutorial tells us what these files are. So that's very important to go through so we understand it. But let me finish the get started section first. So this says to cd into the new directory. So this created the first API directory. So I'll just cd into that. All right. And then run npm install. So this would basically start up our, sorry, this is not start up our server, but this would install dependencies. Whatever is listed as dependencies in package.json is what's going to be installed. So let me run this command over here. And that's going to take a short while to basically install all of these dependencies. So the dependencies we're using are Apollo server. That's for our server. We also have cross-env. I don't know what this is for. We can basically just copy this. It seems that I think we're using it to potentially like start our server or something like that based off of that. But let me find out what this is. Okay, so this is an npm thing. Cross-env makes it so you can have a single command without worrying about setting or using the environment variable properly for the platform. Oh, I see, that makes sense. So just set it like you would if it's running on a POSIX system, and cross-env will take care of setting it properly. Okay, so this takes care of the environment variable, which is why it's written over here. It's interesting. Okay. So going back to the tutorial, it seems like we've already installed everything with npm install. So we have all these dependencies. We know that we have GraphQL, and then there's like a logger that I believe this. So this is part of the tutorial. So that's his logger. So we don't need to worry about that too much. But let's go back to the tutorial itself. So here, Alright, directory structure. So let's look at the directory. And in fact, let me bring this over here so we can view this side by side. Alright, so directory structure, we have the config folder. So this contains one file, although I see two files, but okay. So it contains one file for you to define context, which is an object available to all queries and mutations. So remember in our previous video, we've seen the context argument being passed into the resolver. So this config has a file to create that context. So yeah, so this determines what will be provided to your resolver via context. So this is nice. In this case, we're exporting this function, which will return the request and result. At least that's what we're doing for now. And you can add data you want universally here. By default, it returns the request and response objects only. So that's what we've just seen. The other file is the server configuration to change the port and other things. So server options.js. So we have the server configuration options over here. This will help choose a port. So we can specify a port if we want to, or the default port that will be used is 4000. And this just specifies some server configurations. Yeah. Okay. Then we have the models folder. So this is models. It has books.js. This folder is used to define database schemas or seed data. We'll be using hard-coded data for our exercise today. Okay, so instead of fetching data from maybe a database, we're going to just be using hard-coded data. And so the data is in books.js under models. So then we have the resolvers file. So let's look at that. Okay, so resolvers are essentially like your REST endpoints. They are the functions that run when a particular query or mutation is requested. So in this case, we would need to get the data from books.js. So we have books, and this just says we require this file. And if we go to models and books.js, you see that this thing is what's being exported, which means books is going to be a list of these things. So these objects. Okay. Going back to our resolver, we then have this const resolvers like we usually do in GraphQL for our resolvers, and we're going to be resolving a query. So the top level query will resolve to this. So query can have, you can ask for books. So when you're requesting information, I wonder, yeah, this is JavaScript. So okay, so I was gonna basically write out an example query. So if we want to query something, and based on the structure of this resolver, something you can do is, so something you can do is have a query this way. So you have your query, and then you just have books, and this opens up, and you can specify an attribute of the book. So if you go back to our books, we see that this has a title and author. So let me go to the resolver, and I can specify title. So if I want title, I can specify title this way. So this is an example query that you could have for a resolver that looks like this. So this will return a list of all books. So because books over here is basically just this thing, which is a function with arguments. So 4 arguments for the function. It's an anonymous function here, so it doesn't have a name. So you have parent, args, ctx, and info, and the result of that will be books. So these things. So every single book. And if you do something like this, you'll get the title of every single book. So it'll be a list of titles. Okay, let's look at this. So this is a mutation. So instead of query, you could have mutation. Remember, if you specify something like this, and then maybe the mutation name, you can call it anything you want. So I'm calling it XYZ. So this will make sure that this resolver is used. And you can have add book. So instead of books, I would have the add book thing over here. And I would need to specify any attributes in the arguments as necessary. Okay, so let's look at this. We have the add book thing under mutation, and this again has a function. So this is the anonymous function. Again, it takes in the 4 attributes, and we discussed this in our previous video, and I think we'll talk a bit more about it in the tutorial. So if you don't know what it is yet, we'll talk about it later. But what this will do is once the function is called, it will get the title and author from args.input. Okay. So the mutation will have some arguments. So you just get the input argument, and once you get the input argument, you get the title and author for that input argument. So I'm assuming the input argument might look something like this, but we'll see what it is later. So this is just like a rough thing. It probably will look, oh, where's the, yeah. So it probably will look something like this, I'm guessing. Title could be, I don't know, hi, and then you have author, so this would also need a value, and this can be tree. Okay. So this will be passed into the mutation query, which will probably take in some argument over here. I'm gonna call it input, and this will be of type, so this has to be an input, like the type input, but I have to look into the code to see what this will be. So we'll look at an example of what a mutation will look like a little later, but this is just to give you a rough understanding. Okay, so this mutation adds a book, so it gets the title and author from the input argument, so args.input, so the input field, and then we have books.push title and author. Yeah, so we just have this list of books, so we're gonna just be pushing an object with a title and author to the books list, and then we just return books, so all of the books. Okay, so that's our resolver section. We're also going to have this last line over here called module.export equal resolver. So this is what we'll be exporting if someone does something like this. So it's the same syntax that was used earlier, and it's like common JavaScript syntax. All right, I'm going to remove my comment. I guess I can keep it here to be fair, so I'll just keep it here, I guess. Okay. Next we look at typedefs. So typedefs has this file called typedefs.js, and every resolver, query, and data type has to be defined in your typedefs. This allows your GraphQL server to know what the requested data looks like and what arguments and return values your resolver should have. Okay. Right, so this is just all of the types, I believe. So for the book type, we'll be having something like this. So we know the type book corresponds to something with title and author, and both of those things have to be of type string. And we're going to have type defs for, so we have input new book. So new book will be the input type. And this will be used in mutations. This is what we've spoken about in our previous video, but this will be used in mutations. And type query is just our resolver. So if we have a query for books, this will just return a list of books. And then we define the mutation type here. And so the mutation, when you have an add book, which will take in an input of type new book, so the input type new book, and this will return a list of books. So what's interesting over here, at least for me, is that this type def is a string, but there's this GQL thing in front of it, and GQL is imported from Apollo server. So require Apollo server, and then you have GQL, and that's put in front of the type defs. It's interesting that this is a string as opposed to it not being a string, but I guess this makes sense because what's happening here is they'll just be exporting these type defs as part of this module. But just out of curiosity's sake, I want to see exactly what require Apollo server returns so that we know what GQL is, because it's interesting that they put it in front of the string. So there is a small possibility that they explain this later in the tutorial. Yeah, they think they do, so we'll wait for that, so suspense. But they'll explain it, so it'll be fine. But just in case they don't, I'll put a comment here which says, check this. Yeah. Alright. Let's move on to our next subdirectory, and that's our last subdirectory. That's server.js. Okay, so server.js is our server. So I think we can think about this as like the index.js file. So the first thing that happens. You can think of it like as if like this is where main would be to some extent. You can think of it that way. So this is our starting point. The server.js is the file that kickstarts the server, and it doesn't need to be changed, but we're going to look through what this has. I believe this is very standard GraphQL startup code, but let's look through it anyway. So we have this import for Apollo server and GQL, and we're importing these things from this, and we have the Apollo server, GQL, then we have type defs which we're importing. We're importing the resolvers, and then we're getting our context, server options, and a log. So this is not as important in general, but this is just for the purposes of the tutorial that we have this logger. So we see what our server is doing. Okay, let's move on to Apollo settings. So this Apollo settings has type defs, resolvers, context, cross origin. Wait, I've heard of the term cores before, but I can't remember what this means. Yeah, cross origin resource sharing. That's what it means, the full form. So this is just something that it's a mechanism that allows restricted resources on a web page to be requested from another domain outside the domain. Right. This just basically lets things from this domain be requested by like another domain. So we're sharing it with everybody. That's why we have this section. And the star, the asterisk, that means everything. Okay. So these are the Apollo settings. This is probably in the Apollo documentation, which I should have pulled up now. Alright, I have found the page we need, which is the documentation page. So this has the Apollo server being created, and the options for arguments are type defs, which we have. Right, so type defs, which is a document node or array of document nodes, and that's what type defs is. So it matches the type. There's resolvers, which is a map of functions that populates the data schema. Okay, that's interesting. So this populates data for individual schema fields, and this can be an array of multiple maps that are merged. So in our example, if we were to go to resolvers, we see that this is a map. So this fits what they're asking for in the documentation. Then for context, this is an object. Yeah, this matches. So if we go to context.js, this is an object or a function that creates an object. So this is a function that creates an object. So this is fine. We have data sources. So if we go to server.js, what are the data sources? I don't think we've provided this. Have you provided this? So a data source is a function that takes an object returning data source instances for use by resolvers. Interesting. Is cores even part of this? Because if not, I'm wondering if data sources is the cores thing. Okay, so no, cores is part of, so this is cores. Yeah. So you can have multiple things specified here. You can also specify a logger in the Apollo server, which is interesting. Yeah, there are so many options to explore. So I won't walk through all of this, but I think this is a very nice documentation page to have handy. So I'm gonna just copy this here for future reference. So we know what Apollo settings we can potentially use. Alright, so let's move on to, let me close this because we've gone through that. Let's go back to the tutorial they had really quick and just match up which step we're on, technically. So this is just creating files and installing dependencies. So the dependency they've gotten is Apollo server. We also installed that dependency because that was in the package JSON. Then we define our GraphQL schema. Well, technically, they defined it for us, but we know the syntax of it, right? We've already talked about types in our previous video. So after this, we can potentially add our own type together just to make sure we understand, but I'm pretty sure we understand this. But yes, they've also done the type defs. It's interesting because we have separate files for type defs, but they've included everything inside index.js. I think the approach used in this tutorial that we're following currently with separate folders is cleaner, but in the tutorial they're showing us, they've just put everything in the index file, probably because it's just a tutorial. But yeah, Okay, they then define the index set. So this is actually very similar to the tutorial we're following. They just have different books. Next, they define a resolver. So we've defined the resolvers already. We'll add some more to just practice what we've learned, but we've already added resolvers in resolvers.js. Next, they create an instance of Apollo server. Alright. We've also just done this in server.js. So we create our new server over here with the settings we specified. This is basically launching the web server, I believe. So we launch the web server and we get a URL, and then we take that URL and we just add that to our logger, saying that we've initialized our server. Okay, this is his own logo that he's created. Maybe it has colors based on the wording he's used here, but this is just for logging purposes that he's added this section. Next, they start the server, but we've not gotten to this step completely yet. So let's go back to our tutorial over here. So we've gone through the directory structure, then we have the data. In your models folder, so let's go to models. We should create a file called dogs.js with the following. Okay, so this is just information for dogs. So let's go here, create a file called dogs.js, and just paste that. This is a list of objects with name and age. That's for each dog. Okay, so that's our sample data. Our type defs. In our type defs, we are going to do the following. So we define dog. So we go to type defs. Let's do this without looking at the code, just to like test our understanding. So they want us to define dog in the type defs. So we can add it here potentially, and it's going to follow a very similar structure. So I'm going to just copy this. It's just syntax, right? Anyway, so this is going to be a dog, and from our dog data, we have so name and age. Name is a string, age is an int. So let's go to our type defs. We have dog, the name is a string, and the age is an int. So this is fine. We have the type dog. By the way, this is just a comment, so don't worry about things with the hashtag. Let's just like organize things. He's done it, which is a good idea. Alright. We've defined a dog in our type defs. Then we define a query called dogs that returns an array of dogs. Okay, so in our queries, so here, type query, we need to define a query called dogs that returns an array of dogs. So that's what this will do. So it's an under type query. Next, define an input type. Okay. That's an object argument and a mutation. So we'll need an input type. So we have input. This is going to be new dog. I don't know what he's called it yet, but I'm going to just do this section based on our understanding from the first video. I'll also walk through what he's done just to verify that we've got this right, but yes. So we have input new dog, and the input is going to take in these two fields. I'm going to just copy it because it's the exact same thing, so why not, right? Okay, so we have input new dog. Define a mutation that takes our input type and returns an array of dogs. Right, so I'll need add dog, and this is going to take input So you can call this whatever you want to. Actually, I'm calling it input for now. It doesn't need to match this, but the type of it needs to be of type new dog. And this is gonna, so what does this return? So it returns an array of dogs, but I kind of want to make it different just for fun. Let's make this return just a dog. We'll change our resolver to reflect it. But yeah, so that returns a dog and specifically it's going to be the dog we created. Okay, notice we use tag strings to define our type. This is a pretty cool feature that came with ES6 template literals. The syntax is function, string to be passed to the function. Oh, okay, that's what this is. So this is a function, and then there's a string to be passed to the function, which is this whole string. So it came with ES6. So GQL is a function, and we're just passing in the string into that function. Okay, so let's verify that what we've done matches what they've done. So they've changed it, like removed the book stuff, but I've kept it. That's fine. But they have a comma. I don't know how much that matters, because the initial thing didn't have a comma. So I'm going to try it without the comma. It's interesting. Does it matter? I feel like it actually should, but it probably doesn't. I don't know. Let's figure it out. How have they done it in the GraphQL tutorial? Okay, in the GraphQL tutorial, there are no commas, so you don't need the commas, but you can include them if you want to. Let's go back to our tutorial. So we added what they have, more or less. But remember, our add dog is slightly different because it returns only one dog, and that's fine. We just need to make sure that our resolver matches it. So define our query and mutation. So the next step is to go to the resolvers. So I'm not going to look at what they have. I'm going to try it myself based on our understanding from the video we did, the previous video. So the first intro that we did on our channel. But over here we have resolvers. So I need to add a resolver for everything we've just added. Okay, that shouldn't be as hard. Let's take it step by step. So we added a type dog. Well, specifically, let's go here. So in query, we have dogs and a list of dogs. So I go here. Instead, okay, so we have books in the query. I'm gonna have dogs now. This will take in 4 arguments. I can call this whatever I want to. I'm actually gonna call it object because that's how we looked at it earlier in the first video, but you can call it anything you want to. It can be this, whatever, it's fine. But yeah, I'm calling the second one args. And then context, you can call this anything you want to. Again, I'll call it CTX, I guess, but again, anything you want to call it is fine. So this is the context argument. Next we have info. And as a recap for what these 4 fields do, object is just the higher level object. In this case, it won't make as much sense to use it because we're in like the query stage. But okay, we're in the dog stage here, I guess. So this will be the whole query. Args is just the arguments passed in for this. And context in this case will just be the context passed in, and this is info. So that's information about the type and schema. And this tutorial has it written out here, so you can pause the video and read this if you want to. I guess I'll read it. So parent, this argument contains a parent object. This really only matters if you are using a child resolver. So in this case, this is not a child resolver, so it doesn't really matter per se. Okay, when you start nesting in types, in other types, you can define resolvers that run and have access to their parents' data. So if I had a resolver inside this thing, then maybe object would be useful. Like if I have dogs and then another attribute like friends, I could potentially then use object if I want to access things about the dog. But don't worry if that went over your head, it doesn't matter in this example. So imagine we had an owner type who had a property including the dog they owned, but really was just a database ID. The child resolver can take the ID and retrieve the full dog data. Okay, then we have args. So this contains any arguments passed into the resolver. Only arguments specified in type defs are accepted. Right. So this can only be arguments are specified in the type defs. Next we have context. This is the context object, and this just has anything about the user or the database. It's basically the context, right, as we've spoken about in the first video. And then we have info. It's rarely used, but we just spoke a little bit about it. Okay, so let me not look at that. And in this case, what we want is to add the resolvers. So for dogs, I'm gonna have this return. So I only want one dog, correct? And it's gonna be the dog. Sorry, no, this is the dog's resolver for the query. I don't want one dog, I want many dogs. So I'm gonna have all the dogs being returned here. And I'm gonna copy this and add the dogs stuff here. So we're gonna input the data this way from the dog model. So that should be fine. The next thing that we want to take care of is our mutation query, which is add dog. And this takes in an input called new dog. So we come to mutation, and I'm gonna add dog. So the example over here returns a list, but I want to add only one dog, and I'm going to just return that one dog over here. I mean, I can do both. I'm just trying something different, but this is going to take in the same 4 things. So we have object, we have the args, we have the context, and we have the info. And this is a function. So this is going to, we're going to basically save this new dog and add it to our dogs. So what we can do is have dogs dot push, because we're adding this to our list of dogs, and this push function is just going to take in the attributes of the dog as was passed in by the argument, and the argument name here is called input. We can call this anything we want to. So since we called it input, I can call it input here. So we're pushing input dot, okay, what are the fields of the dog? We have name and age, so input dot name and input dot age. I'm wondering if I can do something like this. So what this is going to do is this is the spread operator, so it'll just take whatever's inside the input and just place it here. So I feel like this should be fine. But let's try it out. Yeah. Okay. So we have this, but we want to just return. Oh, of course, we can't do this. We need to call it args.input. Okay. And then in the end, what we want to do is return args dot input because that's just the dog, right? That one dog that we had. I'm wondering if it'll let us do this, because technically the type of this is input type. It's not a dog per se. So it might actually cause an issue. But let me try this later. So I'll put a to-do for myself so I remember. And I will for now I'll just return a new dog. But so I believe it's actually fine because it could just like coerce it into the type. I don't know, let's try this. So if something errors or goes wrong, this could be an issue. Okay. We'll see how it goes. Something goes wrong, it's fine, we'll learn. Alright, next. Oh, hang on. What am I supposed to do? I've added stuff for the resolvers. There should be enough. But let's look at how they've done it. So they've added this like we have. And then there's the resolver section. For the dogs resolver, it's more or less the same with what we have. And then over here, they've basically just they have the list of all dogs and they're just pushing the input directly like we have. Actually, hang on. Why am I doing this? I'm creating okay, so this is silly on my part. It's a bit extra, but this will actually still work. It's the same thing as this. So what I'm doing here is creating an object after I've used the spread operator, so the dot 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 on args.input. So this will be whatever's inside the object, and then I'm making it back into an object. So instead of doing that, I could just do this, and it's the same thing. But I mean, just to be different and try something different, I will do this for now. But what they've done is better. And then they return dogs, which is the entire list, but I want to return just one dog, so I'm returning args.input. Okay. Next. Okay, it's time for testing. I love testing. Okay, so let's do this. One of the best things about GraphQL is the Graphql Playground. That's true. So let's run the npm run dev command to basically start up our server. And let's see what happens. Okay, it's started up. There is an error, I think, right? Node events. Wait, hang on, did I run this? Yes, there's an error. Emitted error on child instance process. Let me try starting it with npm run start. Interesting. So there's something off with this. We'll figure it out soon. It could be my Nodemon dependencies. It is Nodemon. I'm blind. Okay. So I will look into this a little later. Probably I need to update Nodemon or something like that. But the important thing is we have errors all the time, but we fixed it temporarily. So now let's move on to testing the query. Since we have our server up and running, we head over to the port I've currently specified, and the server options is this or 4000. And yeah, so the port it's using is 4000. So let me just go here. Get query missing. That's nice. I believe that's not what we're supposed to see. So let's figure it out. Get query missing. Let me copy this, paste it. Oh, okay, here's, I think, probably the solution. So we have context, which is fine, and then there's playground and introspection. That needs to be set to true. I think this hopefully might help. Okay. So let's go to npm run start. Let's go here. Yes, okay. So we have the playground. So we found the issue. That's the issue. That's fine. Now we don't have Nodemon, so we need to bring down the server every time we change code. With Nodemon, which is what... So in package.json, I believe if you do this tutorial and there's nothing wrong with your Nodemon file, what will happen is Nodemon will basically just bring should basically bring down and bring up your server when you change code automatically. But since I'm not using Nodemon over here, when I change code, it's not gonna do that. So I have to bring down the server myself and then restart it. But that's fine, because this is just a tutorial, right? So we have this, which is our playground. Now let's move on. First, we put in a query. So let's construct the query ourselves. Actually, it's a query. So based on our resolver, which is over here, our query is just going to be something like this, dogs, and then whatever the dog attributes are. So name and age. So I'm going to just copy it because it's very trivial. So this is our query. And then if we query this, we have an error. Let's fix it. Expected iterable, but did not find one for field. Query.dogs is a list. What did I return in the resolver? It's a list. If I did this correctly. Yes. Interesting. Oh, did I save this? I probably didn't save, I think. Let me try that again then. So let me bring down the server. Bring it up again. If I had Nodemon, I wouldn't need to do this. But let's continue. Right, so that was the issue. I forgot to save the file. But it's okay, we have this now. So it's a list, which is... It didn't see this as a list because I hadn't saved it, so it was a blank file, which is an issue. But this is fine now, and we have the names of all our dogs. One of them has my name, but it's okay. Anyway, moving on to the next step in our tutorial. So we can close this. Okay. Yeah, so you can try it again with specifying only one of the fields or both of the fields, and it'll work. Now let's add a dog with a mutation. I want to try doing the mutation myself. I might mess this up, but it's okay. I'll learn that way, so let me... Yes, that's a comment. Let's go to the resolver just for reference. So for our mutation, so I need to specify that it is a mutation, right? So mutation, and then I'm gonna call this my mutation. Mudog. Actually, Mudog is nice. Okay, so I'm gonna call it Mudog, and it's gonna take in... Okay, it's gonna take in an input. So the argument is gonna be called input, and right, it's a variable, right? So I'm gonna specify that it's a variable of type. What's new dog? Is it called new dog? Hang on, input dog. Let's go to the types really quick. So type defs. Yeah, we called it new dog. So this is of type new dog, and what happened? Okay, this is fine. Let's specify... Oh, how do you specify it? I think it's this way. I don't remember the syntax, but we'll figure it out. We want input to be a new dog, which has a name. I think I should be quoting all of this in strings. Okay, that's the dog's name, and then age. Yeah, something is definitely off with my syntax. Right. What if I do this? That's worse. So this is what I'm trying to do. And then once I get the input, I'll need to figure out how to format this. I look at the documentation. there's a separate button for query variables. So now if I do this, no, never mind. I thought this was the issue. Did I not specify that this is a variable? Could that be one of the issues? I thought it was. Okay. Oh, so okay, this is not my fault. So apparently I forgot to specify a comma, but I've learned that this is how you use the playground. So you need the comma over here. That's interesting. Didn't know that, but now I know. Cool. So we added this dog, and this is with our endpoint, so we just wanted the name of the dog, and we got that. Great. With that, that's basically the end of the tutorial. So we have a GraphQL API. So I actually encourage you to try adding a query yourself, or a mutation yourself, or both. The reason I'm not doing it is because I understand this, and I proved that by basically amending the add dog query to basically just return a single dog instead of a list of dogs. But yeah, try something out yourself. And then this section of the tutorial is just basically fetching information from the server using front end. We won't be doing this because we don't have a front end up and ready. We're just using the playground for now, but this looks pretty simple. So if you want to go through it, feel free to do so. But yes, that's the tutorial. And just comparing this to the other tutorial that's on the Apollo documentation website, it's pretty much the same thing. So you can try either one. But yes, thanks for watching. And it was fun debugging, to be very frank. But yes.